Another important question, light source, point source, is placed at the depth h below the surface of water. Refractive index is mu. Show that the light escapes through the circular area on water surface with its center directly above the point source. Find the angle subtended by the radius of the area on the source. So here the point source, and below the surface of water, here the water is there, right? Then when this is grazing, means here, and there's an angle of critical angle we have to draw. This is the critical angle. Why it is critical angle at a particular angle of incidence? Because at this particular point the ray is grazing the surface. Let this height is h from this to, and this is the circular patch, circular area. यहाँ से यहाँ circular area. That this is the circular area. We can see up to here only. यहाँ पर हमको नहीं दिखाई देगा, अगर ऊपर से देख रहे हैं यहाँ भी नहीं दिखाई देगा, केवल हमको यही वाला पैच दिखाई देगा. इसका हमको एंगल, ये वाला एंगल निकालना है, ये वाला एंगल, एंड we have to show that light we can see up to here only. So let this particular radius is your r. This also r. So how, and this your h height, and we know one formula, sine of the ये क्या है, critical angle. Why it is critical angle? Because this is 90 degree. It's also 90 degree. So critical angle is the particular angle of incidence for which the angle of refraction is 90 degree. ये 90, ये 90. Now sine of critical angle, sine c, is equal to 1 by mu. ये हमको मालूम है, refractive index, critical angle. Now how we are going to proceed it? This c, this also c. So we can write it here, tan c is equal to, in this right angle triangle, ये right angle triangle में हम देख रहे हैं, right angle triangle, tan c is equal to p by b, means r by h, right? R by h, where your c is the critical angle. Now also we can say this r by h is there. We can write r by h is equal to sin c by cos c, लिख सकते हैं, और r by h is equal to, in place of sin c I am writing 1 by mu, by, in place of cos c I am writing 1 by 1 minus sin square c. So I am going to write directly 1 by mu square under root. That comes out to be r by h is equal to, यहाँ कितना हो जाएगा? If you are taking the LCM, 1 by mu by under root mu square minus 1. That is your, ये mu और ये अंडर रूट था तो mu हो जाएगा, तो that is going to cancel 1 by mu square minus 1 under root. The r by h is equal to this. So therefore r is equal to h by mu square minus 1. That radius we have to find out. ये radius हमको निकालना था. So light escapes from the through the circular area on the water surface directly above the point source. So the angle subtended by the radius of the area onto the source, ये वाला C का एंगल क्या हो गया? C का एंगल सिंपल, C का एंगल कोई पूछेगा यहीं से निकाल लेंगे. C is equal to, from here only we can find out C is equal to sine inverse 1 by mu. From here sine C is equal to 1 by mu and C is equal to sine inverse this. So that radius you have to find out. That question is being, if the question is that you have to find the area, then pi r square. अगर area पूछेगा तो pi r square कर देते हैं. R तुमको मालूम है. This normally on the face AB of a right angle prism, refractive index of prism is 1.5. What is the largest angle phi for which the light ray is totally reflected at the surface AC? This is the diagram, just like that. Here it is normally 90 degree है, ठीक. तो ये नॉर्मली ऐसे इंसिडेंट हुआ, प्रिज्म का ये बेस है, तो ये दोनों क्या हो गया? पैरेलल. These two are parallel. So this is phi, this also phi. Now draw a normal on this face, right? So this phi, this will become 90 minus phi, right? This will become 90 minus phi. This angle become 90 minus phi. Total is 90. Now the point is, we have to find out the largest angle of phi for which the light ray is totally reflected at the surface AC. Now what we have to do? Now in this particular case, that angle, this angle, that means we can say 90 minus phi. This 90 minus phi, this is the angle of incidence for this phase AC, should be greater than the critical angle, say the theta C. If it is greater, then only the total internal reflection occurs, right? Here it is given mu is 1.5. If 90 minus theta, this angle of incidence should be greater than the theta C, critical angle. Theta C means critical angle. Then only total internal reflection occurs. So I am writing it like that: 90 minus phi should be greater than theta C. If it is equal to theta C, then the grazing the interface. Then it will graze the interface, right? But I have to find out that at what angle, that is maximum angle for phi for which the total internal reflection occurs, the same medium. So that is the basic. 90 minus theta phi should be greater than theta C. Now we have to use the inequality. So if I am going to write the here sine 90 minus phi should be greater than sine theta C, no problem. Or the sine 90 minus phi is equal to cos phi, should be greater than sine theta C. We know sine theta C critical angle is equal to 1 by mu. So in place of 1 by mu, I am writing 1 by 1.5, or that should be equal to cos phi greater than, we can write the 2 by 3. Why 2 by 3? 10 by 15, 2, 3, like that, 2 by 3. This is the sine. If I am going to change it in this particular sine, the value of sine is, if angle is increasing, the value of sine also increases. But in that is not the case of the cos. In case of the cos, if I am going to inverse it, मान लो हम इधर cos इनवर्स यूज़ कर रहे हैं, cos इनवर्स ऑफ cos phi, then it should be that should be less than cos inverse of 2/3. That's the inequality. cos इनवर्स इधर भी लगाया, cos इनवर्स इधर भी लगाया, तब ये साइन चेंज हो गया. The value of cos, if the in case of a cos, if theta increases, its value decreases. So inequality occurs here also in this way. That should be less than that. So we have to write cos inverse of cos phi is equal to phi less than cos inverse 2/3. That should be the maximum value for phi to occurs TIR. TIR के लिए ये मैक्सिमम वैल्यू होगा, राइट. तो cos इनवर्स हम इधर ले लिए, then it is like that. Inequality changes, right? We can write in this particular manner if we are taking the borderline condition is equal to that also we can write it. That's the borderline, because the angle of in case of the critical angle, if angle of incidence is equal to the critical angle, then it grazes the interface. But for the TIR, there should be a little bit more than the critical angle. Then only total internal reflection occurs.